Hello guys, welcome back to the channel. If you're new to this channel, my name is Abdul Wahab Anemoku, and in this particular video, we're going to talk about early decomposition. So on our channel, as you can see from other videos in this channel, we solve maths problems, undergraduate maths problems. So if you are an undergraduate student and you're taking some maths courses, you will find this channel very useful to you. So let's just get right into the heart of this problem. So what we're going to do is we're going to use LU decomposition to solve these systems of linear equations. So generally, there are several methods that can be used to solve this problem. And as you can see from the linear algebra videos on this channel, which you can find, you could find some of the problems that we've solved with row echelon reduction method to solve this particular problem, or Gaussian elimination, whatever you want to call it. So, but in today's video, we're going to use LU decomposition. So let's quickly see how this works. So now you have this systems of linear equations, and then this can be written as what? AX equal to B, where A is the matrix that comes from the left-hand side of these equations, and the right-hand side is the column vector, right? So in this case, when we bring the coefficient of these linear systems together, we call it that matrix A. So basically, this is what we have, and you have your x1, x2, x3. So we can do this. B1, B2, B3. Now, like I said, there are several methods that you can use to solve this problem. So one of such method is just the matrix method, right? It's called the matrix method. And what this does is basically when you have this system, you kind of take A to the other side of this equation, which gives you your X vector as what? A inverse B. Now, it's usually very costly to compute this A inverse, right? And we have some standard methods that we can use to compute this A inverse. And in future videos, I'm going to show you how to find A inverse. That means the inverse of this matrix. There are several ways to do this as well. So I'm going to look at those in future videos. So on this particular video series, right? Okay, so this is one method. So the second method is the row reduced echelon matrix, reduced echelon form. So basically what you do is you reduce this to an upper triangular matrix, and which is done by reducing this. So whatever you have at the end of this, you can use it to compute your X, right? So you basically reduce this to some matrix U, B star, and from here you can compute your X. We're going to also see an example in this video series, an example using this particular method. I think this is also solved somewhere on the algebra video series, right? So you can go and check that playlist and see it for yourself. But in this particular one, we'll deal with LU decomposition. So let's just go into it so that we reduce the length of time this video takes. Okay, so what is LU? So basically, you now have this, right? So what we're planning to do is, because it's costly to compute this A inverse, so what we do is we decompose this A into two simpler matrices, which is called LU. So basically, we are reducing this, not reducing, we're decomposing A into L times U, where L and U are matrices as well. Then we still have this. So basically, we let A becomes what? LU. Now, U will be an upper triangular matrix, and L will be a what? Lower triangular matrix. All right, I think that's understood. Now, what happens is, instead of solving this directly, what you do is that you break it down. So the first thing is what? You box this one out, so UX. So we substitute another variable for UX. So when you solve UX, let's say it's going to give us Y, right? So we make this substitution, UX is equal to Y. right? Where y is also, what is y? Y would be a column vector, just like how b is, right? And then once you substitute this into what we have here, it becomes ly equal to b. So what happens is, instead of solving this thing at once, we solve it in 2 steps. The first one is, we need to, of course, we'll have to solve this one first. Then once we solve this for what? Y. So we find y. Once we find y, what happens is we now put this inside this first equation to solve for x. So those are the 2 steps that we need to take to solve this problem. So let's just quickly go into it and see how we can find our L. So basically you need to find your L, right, in order to solve this. So we find L, and then you also need to find U, which will be used to solve the second step of this equation. So let's go ahead and solve for L. So let's not forget our matrix. 2 minus, so let's rewrite that. So we have this matrix 2 minus 3, 2, 3, 2 minus 1, 1 minus 4, 2. Okay, so we're going to decompose this matrix now. So let's see how can we do this. So we want to decompose this into L times U. Now, we already know how to get an upper triangular matrix from this is by doing row reduced echelon matrix, right? So what happens is we're going to perform some elementary row operations to this matrix to reduce it to an upper triangular matrix, right? And we use these operations to find L. So let's have L on this side. L is always going to be like this. It's going to be a lower triangular matrix, right? So it's going to have all of this upper part to be to have 0 because it's a lower triangular matrix. But we're going to fill it with this other values in the lower part. But before we get there, basically this is the steps that you have to take. So we're just doing the problem solving. In other videos, I can explain different ways to actually compute this L. So one thing to note is L and U are not necessarily unique. So in fact, they are not unique, right? You can have different decompositions for A, right? So for example, let's say you and your friend work on this problem and both of you obtain different L and U's. You can, it is quite possible for you and your friend to obtain 2 different matrices, L and U, and for both of your solutions to still be correct. So that's what I mean by L and U are not unique, right? So you could find 2 different decompositions, right, for L and U. For this matrix A. Okay, so let's see, how can we get U? So let's perform this row operation. So the row operation is basically you try to make, remember, for you to have upper triangular matrix, you need to get, so let me color it with a different, you need to get these numbers 0, right? That is how you get upper triangular matrix. So we need to find the right row operations to do this. Now, in order to get this entry 0, what do? We use this one, right? The one right here, which is what? Minus, think about it. First of all, you have to make this one, you have to make this entry 1, which is what? 1/2, right? So minus 1/2 of this will be -1, right? Then you have to take into account the value here, which is 3. So basically you'll have to do -3/2 R1 plus R2. All right, I think you've learned this. If you're familiar with this, so basically that's how to think about it. Basically, you want to use this entry to make this 1 0, which is what? -3/2. Think about it. -3/2 times 2 will give us what? -3. So when you add that to 3, that will give you 0. Okay. Now we could also do the same thing for this one. To make this one equal to 0, this entry equal to 0, what do? We do -1/2 R1 plus R3. So this is what you do. Okay, so now the first, we are not doing anything to the first row, so this is fine. Now this is going to change to what? 0, because that is what you were intending to do in the first place, right? Now what happens to this one? So this becomes -3 times -3/2, that is 9/2, right? Plus 2, so that will give us 13/2. So good. What about the third entry? Minus 3 over 2 times 2, that is minus 3, right? Minus 3, then minus 1, that's minus 4. This is what you have here. Now, what happens to the last row? The same thing that happened here will happen to the last row. 1 over 2, minus 1 over 2 R1 plus R3. So what happens is minus 1 over 2 times 2, that's minus 1 plus 1, we get 0. The same thing will happen here. Minus 3 times minus 1 over 2, that's 3 over 2. So we have 3 over 2. Then minus 4, what will happen? That will be, that would give us what? Minus 11 over 2. Okay. So what happens to the third one? Minus 1 over 2 R1 plus R3. So that's minus 1 over 2 times 2. That's minus 1. Minus 1 plus 2, that's plus 1. Right? Okay. So let's move forward. Now, in the L part, the same thing is going to happen here. So basically what we're going to do for the L part is, notice that this elementary row operation, right, is affecting this entry, right? It's making this one 0. So this is what is going to happen here. So it's going to change this part as well. So for the L part, all we need to do is change the sign, the opposite of this is what we're going to put in this entry. So instead of minus 3 over 2, it becomes 3 over 2. It's that simple. Now, what happens to this other one? This entry, this elementary row operation is affecting this value 1. So it's going to change this as well. So we take the opposite of minus 1 over 2, and that gives us 1 over 2. Right? Okay. So what do we do next? Basically, what we do next is we look at the next row operation, okay? Oh, I think there is a mistake somewhere. So minus, I think here, this entry is wrong, it's not minus 11 over 2. So 3 over 2 minus 4, that's basically 3 minus 8 over 3 minus 8 over 2, that's minus 5 over 2, okay. Here's minus 5 over 2. Okay, good. So you have to be very careful when you do this. So the last part is we change this one to 0 as well, right? And we're going to use arrow 2 to do that. So we're going to use the second row to make this particular value 0. So what do we do? So basically, we need to think of what to multiply to 13 over 2 times what to give us 5 over 2, right? Because if we have 5 over 2, then when we add it to minus 5 over 2, we'll get 0. So basically, it means that what? Our x must be what? 5 over 13. So we take 5 over 13, arrow 2, plus arrow 3. This is what we do. So let's see what comes out of this. This will be 2. So we're not changing this. We're not touching this. 0. So now we are touching this. This is going to give us 0, right? 5 over 13, arrow 2. So 5 over 13 times 13 over 2, that's going to give us 5 over 2 minus 5 over 2, that will give us 0. So what we need to complete is the last one. So we have minus 4 times 5 over 13, which is minus 20 over 13 plus 1, right? So minus 20 over 13 plus 1, that will give us what? Minus 7 over 13. So basically, this is what we have. And again, what do we need to do? In the L part, this will give us what? Minus, so let me use the other one. So minus 5 over 13. Yeah, so we have found L, and effectively this becomes our U, right? Because this is what? This is an upper triangular matrix. So this is how we decompose A to find our U and our L. So in the process of getting U, you can get L at the same time, which is basically thinking about the row operation that you are using, and then notice the way I'm taking my row operation, right? I always make sure that the second, so there are a couple of things here. So let's just talk about this. I always make sure that the second row that I'm adding to is always with a factor of 1, right? I do not add, I did not multiply this by 2 or by 3. I make sure that all my multiplication comes from the very beginning. So this is how to do this in order not to make mistakes. So take note of this, right? Always make sure that when you are doing this row operation, the factor in front of the second row or the row that you're adding to should always be 1, right? And make sure that the right factor always comes at the beginning, okay? So take note of this. All right, so now that we have LU, so if you like, this is an exercise for you. Confirm that what this L times U would give us A. So confirm that this matrix L, lower triangular matrix, right? Minus 5 over 13, 1, multiplied by U, multiplied by this. Would give us A, would give us this. Just this will be a good exercise for you. But we could look at 1 or 2 entries to see. So let's look at the, let's focus on the last entry, right? So say 1, let's see how can we get 1 from multiplying this. So basically to get 1, what you need to do is to multiply this, this row with this first column, right? So do that. So 1 over 2 times 2, that will give us 1, right? I mean, that will be 1 plus minus 5 over 13 times 0, that will be 0 plus 0 plus 0, right? So 1 times 0 is also 0. So you get 1. See, it works. So you can do it for any entry and you see that what this matrix actually works. So this is our LU decomposition. Now it's time for us to solve the problem. Now, what's the first step? The first step, if you remember, the first step is to solve this. Is to solve Ly equal to B. This is the first step. So what is our L? So this is easier to write now. 1 over 2 minus 5 over 13, 1 times y. What is y? y1, y2, y3. And B, what is our B from the problem? So we could just check that our B is 946, right? So our B is 946. Okay. So now we can just multiply things out and figure out what y1, y2, and y3 are. Okay. So the first one says y1 times 1 plus 0 times y2 plus 0 times y3 equal to 9. The second equation is what? 9 over 2 y1. So we're using this to multiply this. Okay. So 3 over 2 times y1 is 3 over 2 y1 plus 1 times y2 plus 0 times y3 equal to 4. And the last one, 1 over 2 y1 minus 5 over 13 y2 plus 1 times y3 equal to 6. So this is what we have. So now let's divide this. So we can solve this for y1, y2, y3. So y1 is already equal to 9. Now substitute this into the second equation, which means 3 over 2 times 9 plus y2 equal to 4, which gives us that what? y2 is what? Okay, so this gives us that what? Our y2 is equal to, so let's just solve it in one row. So this means that what? 27 over 2 plus y2 equal to 4, which means y2 is what? 4 minus 27 over 2, which is 8 minus 27 over 2, which is minus 19 over 2. So that is your y2. Now what about y3? y3 is going to be a little bit longer. So it's y3 is 6 minus y1 over 2 plus 5 over 13 y2. So I'm taking everything to the other side, okay? So now let's simplify this. So y1 is 9, right? So we have 9 over 2. Now what is y2? y2 is minus 19 over 2. So just try to figure this thing out. And if you do your calculation, so if you do the calculation correctly, so what do we have? So we can just figure it out together. This is 26. 5 times 19, that is 95, I believe, right? Right. So when you do this, what do you have? So if you do this calculation correctly, that would give us minus 56 over 26, which is effectively minus 28 over 13. Right. Now, this is what we are looking for. So this is the first step, right? Now, what's the second step? Second step is to solve ux equal to y, which means we need to find, we need to go back and get our u. I think we have it here, 100. No, we have it 2 minus 3, 2, 0, 13 over 2 minus 4, 0, 0 minus 7 over 13. So this is u. All right, this is u, and what's our x? X1, x2, x3 equal to our y. And what is y? 9 minus 19 over 2 minus 28 over 13, right? So this is what you need to solve now. So again, you write the equations out. 2x1 minus 3x2 plus 2x3 equal to 9. Good. Second one, 13 over 2x2 minus 4x3 equal to minus 19 over 2. And the last one is minus 7 over 13x3 equal to minus 28 over 13. Now we start from the last one. So if you solve this, you can see that what 13 will cancel out. So this gives us x3 equal to 4. So 13 cancels out, and then minus 7 goes into minus 28 and that will be equal to 4. Now what happens to the next one? So x3 is 4 now, so we can bring this into the next equation. So which means 13 over 2x2 minus 4x3, which is minus 4 times 4, right? So let's just write it. So that gives us 16, right? Minus 16 equal to minus 19 over 2. Now it's easier to solve this if you just multiply through by 2. So if I multiply the whole equation by 2, what does that give me? This gives me, so we're here. This gives me 13x2 minus 32 equal to minus 19. So this gives me 13x2 equal to minus 19 plus 32, which is what? 13 as well. So therefore, x2 is equal to 1. So we have x2 equal to 1, x3 equal to 4. Now now what we do is just substitute x2 and x3 into the first equation, right? So we have 2x1 minus 3 times x2, which is 1, plus 2 times x3, which is 4, equal to 9. So 2x1 minus 3 plus 8, that's plus 5, equal to 9, which means 2x1 equal to 9 minus 5, which is 4, which means x1 is equal to 2. So this is how we can solve this particular problem. So let's go back to, so basically your solution set is x1 is 2, x2 is 1, and x3 is 4, right? So I don't want this video to stay longer than this, so you can basically pause the video at any point in time to see how each of these things were calculated. Right, so basically this particular equation, this system of equations that we have, we can solve it by using the LU decomposition. The first step is you decompose A into U and L, which is what we did here, which is using row reduced echelon matrix method. Then once we've done that, then we can now solve Ly equal to B, which is just multiplying the, so this is what we did here. We multiplied L and Y together, and then we kind of solve simultaneously to find what Y1, Y2, and Y3 are. Once we've done that, the same thing happens to the second step of the equation, which is just multiplying U and X, and then you know your Y now, then you can use that to solve for X. So basically that's how to use this method. You're going to see more examples coming from me on how to use this method so that you can really begin to understand how the method works. Now, this brings us to the end of the video. I would like to tell you at this point to make sure that you subscribe as well as like the video to give popularity to this channel so that other students like you can watch these videos and then gain from them, right? So without further ado, I'll tell you that I'll see you in the next video, right?